Welcome back to the Applied Deep Learning lecture. Let's dive into it. I would like to start with a question. Is this email spam? Congratulations, you've won 650,000 euro in the monthly Euro Million Google promo lottery on April 26, 2019. Please consult this email address for claiming your winnings and provide us, obviously, your full name, address, birth date, credit card number, and of course, the CVC checksum. Well, I think that's pretty easy. Of course, this is spam. But how about this one? Greetings, I'm Miss Margaret Komeiri, Deputy Chairman and Managing Director of the Chongqing Bank Limited. I write briefly to seek your collaboration in a multi-million transaction with good return for us on participation. Reply for details. Probably spam too, but it's already a bit harder to understand. And the reason why this might be a bit harder to understand is, in the first one, you can simply filter for some keywords, like credit card, lottery, winnings, and then make a decision on this. With this email, well, you already have to understand a little bit more context. Is the person who's talking here like a legitimate person? Maybe the person receiving is an investment banker and they get actually these emails frequently. So it's not as easy anymore as you think. And what you might need here is context. Another example. What do you see? Well, I guess we all see a cat here. But if you would ask the computer the very same question, how should it know? If you were asked to write a program that makes the computer able to actually answer this question, what would you do? Well, you could think about it the following way. There are some characteristics that cats have. They have pointy ears, they have whiskers, they have eyes that have a certain shape. So you could start implementing some methods to try to find these things. And this is what a lot of people have done in the past. They implemented manual classifiers, feature extractors, and tried to solve this and similar problems for a long time this way. What do you see? A muffin or a dog? While this is a more humorous example, the problem still remains the same. When you try to build or write a software application that can classify images or do certain things, classical programs that, like have if-else conditions and then you try to compute some function, it can quickly reach its limits in certain situations. And exactly in those situations, machine learning can be a viable alternative to this imperative programming style, especially when you can use data to answer these questions. So this is what machine learning is all about. Trying to extract patterns and answer problems using data. And these two parts here that you have in this definition, using data would be the training part, where you try to extract relevant features, patterns, and information, and then you can perform inference to actually apply it to some new unseen data to answer these questions. A few words about the terminology first. Artificial intelligence is, well, a bit unclearly defined. I would say it's mostly used as a marketing term, so you will hear it a lot if you work in the corporate worlds where you want, to promote your project or your product, and then of course everything is AI. But the definition is not as clear here, so I will try to avoid it as much as I can. However, what is clearly defined is machine learning. Machine learning is, as I just said, using data to answer questions. And an example could be linear regression. You have a couple of points and you want to fit a line in there. Within this realm of machine learning, there is actually one specific sub-area that is the one that we are going to focus on, which is representation learning. So ideally, you use the data to answer the questions, but you don't want to use all of the data all the time, like in a k-nearest neighbor classifier. What you want to do is you want to do the you want to extract some representation which you can use to efficiently answer those questions. And one particular topic within the representation learning area are these neural networks that we will talk about in a minute. And if you have neural networks and they become quite deep, then this is what we would call deep learning. So how does deep learning work? Well, the key ingredient is that it tries to find and learn a meaningful representation, as we just said. So in order to understand whether an image contains a car, a person, or an animal, it would be helpful to see or to know whether there are wheels in there, eyes, cat has pointy ears. So all of these interesting high-level features can be used to answer this question. So it would be great if we could have a representation that can extract these high-level features on its own. And this is exactly what we are doing with deep learning. So we're learning high-level features that help us to answer these questions. And these high-level features are based on mid-level features and low-level features. Like we're starting with colors and lines, and then we're merging these features into more high-level features, and ultimately we have something like object parts and objects in our neural network. And the best part about this, all of this is learned on its own. But how can a machine actually learn? Well, we're starting with the first ingredient, a model. A model is a set of computational rules that we can tweak in order for the computer to take an input and produce an output. The second part is the loss function. The loss function tells us basically how good are we doing. So we can run a sample through our model, get some output, and then compare it with the ground truth to determine whether we're actually doing the right thing or not. And last but not least, if we have a set of computational rules, we know how good we're doing, well, we need to have a third part that actually helps us to get better. And this is our optimization function. And with these three things, we can actually teach a machine to learn something. One example of what you could do with such a trained model would be image classification. I already mentioned it several times, and if you're interested in more about this, the Deep Learning for Visual Computing lecture actually focuses on this specific problem. So there you will be implementing a project specifically with this problem. Now you might ask, well, yes, now I've trained a machine to distinguish between cars and cats and dogs, but what good is that for? Well, there are actually a great number of applications of image classification. For example, if you have skin lesions, you could try to understand, is this a melanoma or is this benign? Is it harmless? And if a computer could tell you this in a very reliable way, it could assist doctors and obviously help people to, not suffer from melanoma. Another application could be object detection, where you try to find objects in an image. One example here on the left is one of the results from my PhD, which was an object detector applied to sheet music, where you can see all of the note heads and stems have colorful boxes around them. Nowadays, you can also already recognize the voice and have some kind of natural conversation. And this example is already a couple of years old, but I still really like it, how they have Google Duplex calling a hairdresser to book an appointment for you. Let's listen to it.
So how can I help you?
Hi, I'm calling to book a women's haircut for a client. I'm looking for something on May 3rd.
Sure, give me 1 second.
Mm-hmm.
Sure. What time are you looking for around?
At 12 p.m.
We do not have a 12 p.m. available. The closest we have to that is a 1:15.
Do you have anything between 10 a.m. and 12 p.m.?
Depending on what service she would like. What service is she looking for?
Just a woman's haircut for now.
Okay, we have a 10 o'clock.
10 a.m. is fine.
Okay, what's her first name?
The first name is Lisa.
Okay, perfect. So I will see Lisa at 10 o'clock on May 3rd.
Okay, great. Thanks.
Great. Have a great day. Bye.
If you have an agent that can make a call on your behalf, of course, there are also some downsides. So one downside of this are so-called robocalls, where a machine calls someone. And I really would love to share this one clip here from Last Week Tonight by John Oliver, which is, I think, a really, really nice example of one of these robocalls going wrong.
Well, I'm calling about an online request you once made about health insurance coverage.
Okay.
I work with all major companies and compare...
Hey, are you a robot?
What? No, I am a real person. Maybe we have a bad connection. I'm sorry about that.
Will you tell me you're not a robot? Just say I'm not a robot, please.
I am a real person.
I mean, I believe you, but will you just say I'm not a robot? It'll make me feel better to hear you say it.
There is a live person here.
If you could say the words, I'm not a robot, it would really mean a lot to me.
I am a real person. Can you hear me okay?
Right, but will you say I'm not a robot?
I think the funny part about this call was that this journalist who got called here was actually doing an article and working on researching robocalls when he got this robocall. So it's a very nice clip, and I highly recommend this TV show. Another example of what you can do nowadays is working with music and harmonizing melody. So let's listen to an example of the Deep Bach project, how they took, a melody and then created or let the machine harmonize the other three voices. Let's listen. Sounds really nice, right? This model was specifically trained to harmonize in the style of Bach, and I think the results are pretty impressive. You can also come up and generate entirely new music, and let's listen to a short clip of how I've created some music by just hitting some keys on my computer.
Tangled thoughts and knots, neurons sparking what we've got, chasing ghosts in binary rain. Backprop flows like rivers deep, optimism
There are other examples that I want to dive into briefly, which I believe are really impressive and have really made the rounds in the last couple of years. One example is generating images from text. And when DALL-E came out, the first model that was able to do this, it really made a splash. When you could say, well, give me an illustration of a baby fox in a suit playing guitar, it produced really nice results here. And this development is still ongoing and really exciting. And I think this one really demonstrates well how the model Midjourney, or the company Midjourney, generated different images over time of a hyper-realistic image of Harry Potter, and how it got better and better and better over the years. So I'm already looking forward to see how the next couple of rounds are going to look like. But I think the results here are extremely impressive already. There's only one step to go next, which is generating videos. This is a really nice example. You see the text prompt that was fed into the network here. Let's see what it produced.
According to this old sea chart, the lost island isn't myth. We must prepare an expedition immediately.
Wow. I think that's pretty impressive in terms of quality and, the prompt following of what the user wrote there. Another example of something that I think as software developers we are going to see more and more in the future is machine learning models actually writing code. Here is an example of an OpenAI model that wrote some Python code based on a short description of what the function should do. And the most funny part about this is that a few years ago, some students came to me and asked, well, can we actually create a model that does the assignment for us so we don't have to do anything? And I was like joking, said like, I don't think that's possible anytime soon. And well, look at it now. Now we have models that can actually write software code, run it in an agentic mode, and also do code reviews, etc. So I think this is something, an interesting development that will only continue to be like this. Another example that I personally found really interesting when it came out was DeepMind's StarCraft 2 model. So let's have a look at what's going on here. In case you haven't seen this, I really recommend watching the full 2-hour recording of this. So you have this real-time action game where you have to control the units to play StarCraft 2. And on the left, you see AlphaStar, which is the model that DeepMind created. And on the right screen, you see Mana, like world-class champion player of this game. And the machine takes the raw observations, like where on the map some units are and what is currently on the screen. And then there is a model that can actually consider like where to go, where to look, and decide which actions to take, like send a unit there, build something here. And you already see on the right top the loss function here, which is the outcome prediction. And at this point, the machine is already pretty certain that it will win against the human based on some characteristics about number of resources, units, etc., etc. And the interesting thing about this was, I think they played 4 games against each other, and 3 times the computer won. And only in the 4th game, Mana was able to actually beat this machine because he exploited basically a bug where he was sending the units back and forth, and while the whole army of the enemy was busy, he actually came from the back and defeated the enemy player. The last example that I want to give you is from the field of chemistry. And the problem here is the 3-dimensional structure of proteins and how to fold them. So while we know the chemical sequence, the thing that we do not necessarily know is how in a 3-dimensional space proteins are folded. And why do we need to know this? Because based on this 3-dimensional structures, proteins have certain abilities, certain properties. And I remember it was maybe 10, 15 years ago, there was a game where it was like a gamification of this, where they tried to interest humans in playing this game to try to fold, because humans apparently were much better at kind of seeing 3D structures and trying to fold it. And only a couple of years ago now, AlphaFold actually managed to develop a machine learning model that was able to fold proteins successfully and compute what three-dimensional structure is needed in order to create and fold this protein. So this is a huge advancement in the knowledge of humans, and I think also one of the most interesting things, how you can apply deep learning to be a force for good. Summing up, machine learning can be an alternative to imperative programming. Machine learning itself, I would define as using data to answer questions. And I hope by the examples I've given you and showed you, you feel also inspired and motivated. And I believe deep learning can do some pretty cool stuff. That's all for today. I wish you a great day and see you next time.